Hello, right, here we go, GCSE reset. Now what we've got here is the paper that we partly went through this. Now I know it's the higher, and this will do for the foundation people as well. Now paper 1 non-calculator November 17. The first, I think, 12 questions appear in both papers. So this is the 12 that are pretty necessary to try and get right if you're doing the higher paper, and 12 of the higher level 4-5 papers, 4-5 questions in the lower paper, foundation paper. So you need to get a lot of them right, yeah? Okay, let's work through them. Okay, 2 to the 6 plus 6 squared, square root. Well, 2 to the 6 is 2 times 2 times 2 times 2 times 2. How many times is that? 6. So 4, 8, 16, 32, 64. And 6 squared is 36. Now, if we're adding these two numbers, we've got 64 plus 36, all the square root, which is the square root of 100, which equals 10. 800 million in standard form. So let's write 800 million as a number. Now, standard form has got to begin with a number between 1 and 9.999, 1 and 10. So that's no good because that's 800. That's no good because it's 0.8. So it's one of these two. So take your decimal point where you're going to go after the 8, which is there, and then count 1, 2, 3, 4, 5, 6, 7, 8. 8 jumps to get right to the end, which is 800 million, and it's 8. So it's there. 4a5 squared. Now, so what we do is we take this there, a5 squared, and we square this one, the a, and we square the 4. So 4 squared is 16, and a to the 5 squared is you multiply these two numbers together, laws of indices, so you get a to the 10. So it's going to be that one. Right, y equals 10 over x. If the values of x doubles, what happens to y? So let's see, let's make up a number for x. So we start with y equals 10 over, we'll call it 1. So 10 divided by 1 equals 10. So when x is 1, y is 10. So let's double x. So y equals 10 over 2 equals 5. So when x is 2, or when x has doubled, y has halved. Divide by 2. This one, difference of two squares. So we do the two brackets, we're factorizing, and so we need to find a square root of that, which is x and x. Square root of 100 is 10 times 10, and we need a plus and a minus. Difference of two squares. Solve. X on both sides. So get rid of the smaller number of x's. So subtract 2x from both sides will give us 5x plus 6. Don't worry about the greater than, less than, whatever that sign is. It makes no difference at all. Now we need to get rid of plus 6. So subtract 6. 5x. 1 take away 6 is minus 5. Now we've got 5 times x, so 2 the opposite, divide by 5, which gives us x, and minus 5 divide by 5, which is x is greater than, that's 1, 5 times 5 divided by 5 is 1, but it's a minus 1. Right, this one, the square root of any square number is itself. So the square of any square root number is itself. Is that what I said? So that times that is just going to equal 3. And the other one, square root times square root of 2 equals 2. So this becomes 3, this becomes 2, multiply the 2 together and you've got 6. Terms of pi, don't need 3.14, just terms of pi. Now this line here is going to be the radius of the circle, because if it was all the way around, it would be the radius. So what do we do now? So area equals pi r squared. We've got a quarter of a circle, so let's divide by 4. So r squared is that, 6 squared, so that's 36. So we've got pi 36 divided by 4. 36 divided by 4 equals 9, so it's just 9 pi. Doesn't matter whether you put pi 9 or 9 pi, easier to say it with a number. Right, the three whole numbers are each rounded to the nearest 10. The sum of the rounded numbers is 20. What's the maximum possible number done for the three original numbers? So now we've got to find numbers that round down to 10. Now we're keeping whole numbers, yeah, whole numbers. So we need the biggest number that rounds down to a 10. And all three of them we've got to add up to 70. So if we think that 30 plus 30 plus 30, oh, no, not that, is it? That's going to be 90, isn't it? 30 plus 30 plus 30, 10 equals 70, yeah? So we need the biggest numbers that will round down to 30, 30 and 10. So that would be 34 could round down to 30, 34 and 14. And add those three together and you get 82. What happens if we chose different numbers? Say we chose 50 plus 10 plus 10. That makes 70, doesn't it? Yeah. So that would be 54 plus 14 plus 14. And 3 fours are 12. And 5, 6, 7, 8. 82. Doesn't matter which numbers you choose, it will always come out the same. Now, circle the expression for a range of n consecutive integers. N consecutive integers. Whew, right, let's have a look. N consecutive integers. So it's n plus n. A range. Oh, there. Now, so let's do some consecutive integers. Just random ones, yeah? 2, 3, 4, 5, and 6. Okay, so we've got 5 integers and the range is between 2 and 6. So the number of integers we've got is 5 and the range we've got is 4. So it's going to be n minus 1 will equal the range, wouldn't it? N minus 1. 5 take away 1 equals 4. What if we do different ones? 10, 11 and 12. Now that we know that the range is equal to 2. So the numbers, we've got 3 numbers. If we take away 1, we equal 2. So that will be n minus 1 equals the range. So it's n minus 1, that one. Oh, don't like the look at this one. 3 identical isosceles triangles. Yeah. Work out an expression in terms of B and H for the area of the trapezium. Now the area of a triangle, one of the areas of the triangles is equal to half base height. And we've got 3 of them, so let's multiply that by 3. Okay. Now, can we simplify that? Yeah, 3 times a half equals 1.5 or 1.5 times the base times the height times the base times the height. So there you go. So there's an expression using B and H for the area of the whole trapezium, because we've got 3 isosceles triangles or 3 triangles. Now this one, this is Work out an expression just in terms of B for the perimeter of the triangle. Right, so, and we've got between B and S, there's a bit of a, so we've got a B, a B, and a B, and an S and an S for the perimeter. So we've got 3B plus 2S equals the perimeter. Now it just wants to do B's, so we don't need the two S's. Yeah, we don't need the two S's. Now if we've got this B to S is 2 to 3, and we've got two S's, so it's like having three B's and two S's. So if we have 1B, that will equal half of that is 1.5 S's. So 1B is 1.5 S's. So the S is 1.5. So this 2 times 1.5 is equal to 3. So 2S is the same as 3B. Therefore, we've got 3B plus 3B, this is difficult, this one, which equals 6B. 6B centimetres. Awkward, not happy about that one. Now 11. The four candidates in election were A, B, C and D. The pie chart shows the proportion of votes for each candidate. Work out the probability the person who chose at random, voted for C. So everything is 360, and we know something about all of these. So if we know that all of that added up together is 360, we can find out the value of X, then we can find out the value of C and work out what the proportion was. Right, so A is 90, B is X, C is 2X plus 10, and D is 2X, and that all equals 360. So we need to tidy this up a bit, don't we? So we've got 90 and 10 is 100, and how many X's have we got? We've got 5X equals 360. So take away 100, 5X equals 260, and then divide by 5. 260 divided by 5 is 26, 52. So X is 52. So the probability, now we've got X is 52. So that will be 2 times 52 plus 10, which is 114. Yeah? So it's 114 out of 360, because that represents 114. So that's the probability of somebody voting for C. Ooh. Right, so this is the last one that appears in both papers, right? Use approximations and significant figures to estimate the value. So significant figures is anything after 0. So this first number becomes 0.5. This one is going to be 40 to one significant figure times 40 squared. And this one, 97, is going to be 100. So 4 fours is 16. 4 fours is 16. 40 times 40. 40 times 40. Get the number of zeros right. 0, 16. So 1600. So I've got 0.5 times 1600 divided by the square root of 100 is 10. So half of that is 800 divided by 10, which equals 80. Yeah? So there are all the questions, whether you're doing higher or lower, that appear in both the foundation and the higher paper. Okay,